Hey everyone, in this video I'm going to solve probability questions from Cambridge Mathematics IGCSE Past Papers. So a bag contains red beads and green beads. There are 80 beads altogether. The probability that a bead chosen at random is green is 0.35. Find the number of red beads. So first of all, we are given the total number of beads together, that is red plus green, right, which is 80. And we are also given that the probability that a bead chosen at random is green. So this is the total number of beads together, all together. So that's why it will be in the denominator, because it's out of that. We don't know what is the number of green beads, but we know the probability that it is chosen at random will be 0.35. That means green, imagine green is denoted by the letter G, right? So this is green, basically, green beads. Green beads. Okay, so G is the number of green beads out of the total number of beads, that is 80, okay, is equals to 0.35. So what is the number of green beads? G equals to 0.35 multiplied by 80. That will be equals to 28. Total number of beads is 80. So we'll subtract 28, right, from 80. That's going to give you. So that means that this is the number of green beads, right? Because we found G. So this is the number of green beads. So we subtracted from the total number of beads, total number of beads, that is 80, the number of green beads, and we found the leftover beads, that is the red beads, the number of red beads, right? So that will be 52. Marcos chooses a bead at random and replaces it in the bag. So he replaces it, all right? He does this 240 times. Find the number of times he would expect to choose a green bead. So this is very easy. You have 0.35, which is the probability of him choosing a green bead a single time a single time, right? Once, if he does it, the probability of him choosing a green bead will be 0.35. So if he does that for 240 times, right, you'll have to multiply it. He repeats that 240 times, so you'll multiply it with the probability of him doing it once. So that is 0.35 multiplied by 240. That is 84. The next question is that a different bag contains 2 blue marbles, 3 yellow marbles, and 4 white marbles. Okay, 2 blue marbles, 3 yellow, and 4 white marbles. Huma chooses a marble at random, notes the color, and then replaces it in the bag. She does this 3 times. Find the probability that all the marbles are yellow. So she chooses a marble, right, at random from all these marbles. Total will be 2 plus 3 plus 4, which is 9. So the total number of them are 9. So out of 9, she chooses, so out of 9, she chooses uh, one of the marbles at random. She'll place it back, and then again she will choose it. So they're asking us that what is the probability of that, all three marbles are yellow. So first of all, we'll go with first. She replaces it, all right? Okay, so in the first time, the probability of her choosing a yellow marble is 3 out of 9, right? The second time she will choose the probability of her choosing a marble, yellow marble, will be also because she replaces it back. So it's not like she's taking one marble and keeping it with her. She's putting it back, right? So again, it will be the total number of marbles are not changing in the back, right? So it's 9 itself. So that means that again it will be the same number because there is no change in the number or the colors of the marbles. So it will be again 3 out of 9, and again you will get that as 3 out of 9 because she is going to repeat this 3 times, and all 3 times she will, all the time she will get the same amount of probability, like that is 3 out of 9 multiplied by 3 out of 9 multiplied by 3 out of 9, and that is 1 out of 27. Okay, so find the probability that all three marbles are of different colors. Okay, so what we need to know is that first of all, she's replacing it, so the total number of marbles in the backs are always going to be out of 9. So I'm going to write that out of 9, out of 9, out of 9. Now we need to know that there is white color, there is blue color, there is yellow color. So each time she cannot repeat it, like, because there are three marbles that she's choosing and all these three colors will be there. She cannot choose white, white and blue, or she cannot choose blue, blue, blue. So she will always have to choose white, blue, yellow. But the order can differ, right? So the order can differ. It's not that she's just restricted to WB yellow Y, which is white, blue, yellow. She can choose Y, B, W. She can choose Y, W, Y, W, B. She can choose Y, W, B. She can choose B, Y, W, B, W, Y, and WYB. So she can choose all these, all these orders. It doesn't matter. They're not asking us like which order is it. They just asked us that the marbles that she will choose will be of three different colors. So this is 1, 2, 1, 2, 3, 4, 5, 6. These are the 6 different possible orders that she can choose, right? And all of them are satisfying the question that she's choosing three marbles. All the three marbles are different colors, right? So it does satisfy the question. So basically what you have to do for W, it is, what is the, wait, how many W were there? White, there were 4 out of 9 multiplied by, blue is 2, so 2 out of 9 multiplied by, which is Y. Okay, Y, yellow. Yellow is 3 out of 9. So this is the probability for the first order. We will add it with the probability of the second order, which is yellow, blue, W. So that is going to be yellow, blue, W is, yellow is 3 out of 9 multiplied by 2 out of 9 multiplied by 4 out of 9. So we'll have to do this 6 different times for all of the different orders, right? And it's going to take place, and we won't be able to like, a lot of time will be consumed doing that. You can see that the amount, if you calculate this 4 into 9 into 4 into 4 divided by 9 multiplied by 2 divided by 9 multiplied by 3 divided by 9. If you add, this is basically the same amount as this. So what you could do instead, I will just tell you what this is, right? 8 over 243. So you're just adding these to 43, right? And you would get, like, if you do it 2 times, if you add it, it's fine, but then you'll have to do the same thing again and again 6 times. So instead of that, you can write multiplied by 6 instead of writing the whole thing, because this is equivalent to also 243 multiplied by 2. So you'll have to do this again and again for 6 different time orders. So instead of doing that, you can write 4 out of 9, 2 out of 9, 3 out of 9 multiplied by 6, and you will get your answer without showing a lot of detailed working and consuming your time. And the answer is 16 over 81. Your answer. The next question asks us that another bag contains 2 green counters, okay, and 3 pink counters. Teresa chooses 3 counters at random without replacement. So now we have a question without replacement, right? So without replacement, that means that every time the number of uh, counters that she will choose, it will be subtracted. Imagine this is n. Imagine this is n. It will be subtracted by n minus 1. I mean by 1, right? Again, it will be n minus 2. So because she's not replacing it, she's not keeping it back, right? So find the probability that she chooses more pink than green counters. So first of all, over here they asked us that they told us that she chooses 3 counters. So that's limited for us. Okay, so basically the total number of counters that are there is 2 plus 3, which is 5. And she will do this 3 times. She will choose 3 counters. So as I've told, 5 minus 1, this was 5, n is equals to 5. 5 minus 1 will be 4. Because she doesn't replace it, so she will just keep it not in the bag or wherever she took it from. Yeah, from the bag. She will not keep it back. So of course the number of counters that is left in the bag is 4, right? Because she hasn't replaced it. Multiplied by, okay, so in the denominator, the total number of counters that are there will be now 3. So every time she will take 1 counter and she will not keep it back. So of course the total number of counters will decrease. Now the question is that find the probability that she chooses more pink, right, than green. So there are 3 pink counters that we know. So first of all, she can choose 3 pink, right? Or she can choose 2 pink and 1 green. Now she cannot choose like 2 green and 1 pink. Alright, so 3 pink, she can choose 3 pink counters. So that would be 3 out of 5 multiplied by 2 out of, because now why did I do 2 out of 4? Because she already took 1 pink. So again, the same thing, she's not replacing it, right? She's not putting it back in the bag that she took it from, right? So that means that already 1 pink is gone. Now there would be 2 pink counters left. Similarly, if she takes away in the third time, if she takes away in the second time she took away another pink, so that means there would be just 1 pink left for her to take, and she takes it. So that's why it would be 1 out of 3, right? So every time she does it, she took 1 pink. So that's why there was out of 3 pink, she took 1 pink, so that's why it became 2 pink here, and she's not replacing it. So be careful. If she was replacing it, then it would be like the previous question. The probability would remain the same. It would be 3 out of 5 multiplied by 3 out of 5 multiplied by 3 out of 5. But over here it is without replacement, so that's why this is the difference. Okay. So this is not just the scenario. We're not done with our question. So this is not just done. We only finished for 3 pinks and 1 green. So she can choose 1 pink, then she can choose 1 green, and then she can choose 1 pink, right? She can choose 1 pink, another pink, and then green. Or she can choose green first, then pink, and then another pink, right? So these are the 3 orders that she can follow, or she can take either to satisfy this 2 pink, to satisfy taking 2 pink and 1 green, because they don't mention the order of choosing the colors, right? So somewhat similar to the previous question, right? But yeah, similar to the previous double I question, B double I, but over here, but then the denominator was same, because of course it was because she was replacing it. Over here she doesn't replace it, it's without replacement, so that's why it will be different. The denominator will be different. So again, it's going to be, this will be, okay, so what is pink? The probability of choosing, okay, so what is the probability of choosing pink first? 3 out of 5 multiplied by green, which is 2 out of 4. See, I'm changing the number of total um, beads, right? Or no, not beads, counters. So it's decreasing because she's not replacing it. So that's something you have to be extremely careful about. Then the number of, again, pink beads, because she has to choose. So now you see this over here, you have to be very careful. From, she already chose 1 pink, so, and she hasn't replaced it. So now it's not going to be 3 out of 3, right? She has already chosen 1 pink and she didn't replace it. So now the number of pink counters that is left in the back is actually 2, right? So out of these 2, she has a probability of 2 out of 3 counters to be chosen as pink, right? So this will be your probability, like finding for 2 pinks and 1 green. But as we are not given any order of how she will choose it, you have 3 different orders that you can choose from, as I have mentioned over here, right? So that's why, like in the previous question, we multiplied, because we had 6 different orders, we multiplied this probability, right, for one order with 6, right? So we're going to do that. We had 3 orders right now, so we're going to multiply 3 different orders. We found only for 1 order, which was pink, green, and pink, but we can do it for pink, pink, green, and 3 orders I have given you. So you need to multiply this. I'm going to put a bracket here to show that it's going to be multiplied only with this. So multiply this with the number of orders that were possible, and we found out it will be 3, right? So that's how you will get, that's what you have to do. You have to multiply it with 3. So let's see what's the answer for this. I got it as 7 out of 10. Okay, so that is your answer. So now we're going to go to another question, and it's from another paper, so it's not from the same paper. Okay, so now I came to another question. That was the end of that question. So this is from another paper. So over here it says that Essen has a bag with 5 green counters and 4 red counters. She takes 3 counters at random from the bag without replacement. Work out the probability that all three counters are all the same color. So this is really similar to that question. So she takes five green. Okay, the bag contains five green counters and four red counters, right? So she takes three counters, right? At random without replacement. Be careful about this word, without replacement. This is going to actually change, like the procedure of you calculating for probability will change, whether by reading or just by the question stating that she replaces it, or without replacement she doesn't replace it, right? So over here, they're asking you that work out the probability that the three counters are all the same color. So they have to be the same color, right? That means that it can be green, 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 and it can be red, 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 right? Now, yeah, that's it. So basically, green, 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 green. So we'll start with green, green, green. This is I believe it's more easier than the previous one, because there isn't any order that you can, like, that you need to care about, because it will be G, 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 and it's R, R, R. There is no other letter that comes in between to differ the order, right? If it was G, R, G, so you could differ and write it as R, G, G, or G, G, R. But right now you have three uh, colors that have the same, that are all green, 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 and red, red, red. So you don't really have any order to care about, right? So it will be just one order. So it's going to be basically 5 out of um, the total number of counters, that is going to be 9. Okay, divided by, now she took 5, right? There were 5 green counters first without replacing, so she doesn't put it back to the green, she doesn't put it back to the bag, in her bag. So now the number of green counters left in her bag is 4, and the total number of counters left in her bag is 8, because she doesn't replace it. And this is a very, very important um, word, or this is an important direction that will actually determine your whole calculation will be depending on this. Is she replacing it or not? And then after that, you will have to multiply again, so she doesn't replace it again, so that you'll subtract it by 1, and that's going to be 3, right? And she doesn't replace, she took away 2 already from that 9, so now it would be out of 7. So this will be the probability of finding green, 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 right? And the probability of finding red, red, red would be 4, because 4 red counters divided by 9, that's the total number first of all, without replacement, so it will decrease by 1. Of course, she doesn't put it back to the bag, so 3 by 8. The total number of beats or counters will also change, as I've told you earlier, and this will be 2 out of 7. So the answer for this is, that's going to be 1 out of 6. This is a 4 marks question, and if you are careful about the direction that you are given, you'll easily be able to solve it. Okay, so that's all for the probability tutorial for today. If you have more doubts in probability questions, you can let me know in the comments below. And if you found this video helpful, please like and subscribe to my channel and share this with your friends. And if you have more doubts from other topics, right, so you can also let me know in the comments below about them. Keep watching. Thanks.